Good morning, everyone. This is Shauna, and I'm coming to you this morning with a brief walkthrough of section 4.2. A lot of the problems in this section vary, and they use concepts that we've used in the previous section, but the major idea here that we want to focus on is an idea called exclusivity and whether two events are mutually exclusive or not. Okay, so let me go to the slides at this time. And let me show you, here are the slides for the section. And as I've mentioned before, two events are mutually exclusive if their sample spaces don't overlap. They don't have any possible outcomes in common. So this could be things like rolling a single die and getting an even number and getting an odd number. You're going to get either one, not both together on a single roll. Also in my previous video, I mentioned when we were looking at 4.3 that when you see the word or, because we had some problems in 4.1 that dealt with or, I want you to think of addition when you're using probability. But there's two addition rules. There's the one for mutually exclusive events where they don't overlap. And there's one for non-mutually exclusive events when they do overlap. So essentially, if you take out the overlap, then you're using this rule here. Okay. Now, we've talked about card probabilities before. I want to talk a little bit about dealing with tables, because we're going to have a lot of tables in this section, and I'm going to show you a couple of those on the homework. But when you're dealing with tables, if you don't have totals in your rows go across, columns go up and down, just like the columns on a building are up and down. They're not horizontal, okay? You want to get row totals and you want to get column total before you do the problem, okay? So in this case, 72 plus 81 plus 5 and 103 plus 68 plus 7 with the respective column totals. And if you notice on the next slide, that's exactly what she does. 72 plus 81 plus 5 is 158. 103 plus 68 plus 7 is 178, and so forth, okay? You need to get these code totals so that you can actually do or answer the question that it's asking, okay? So one moment, please. I have a technical issue here. All right, so now I'm going to answer this question. The person has no opinion. Well, find the people who have no opinion. That's 12 people right here. Total of 12 out of the total number that you talked to, which is 336. Notice that this is the number of people who fit the category, the number of ways to have the event over the total number in the sample. Okay. Then she reduces the fraction, gets the decimal, and converts it to a percentage. Okay. Now, let's look at the next slide. The person is male or is against the issue. So here, okay, we have to look. Now, males are this first, oops, my apology. Males are the first group that we see here. Here are my males, all right? Now, those are my males and no opinion, okay? So right here, male and no, they're against, I'm sorry, they're opposed. So that's this group, all right? Well, in this case, those events overlap. Why? Because the males are going to include the males who said yes, the males who said no, and the males who have no opinion. And the people who are against the issue are going to include both male and female. So we have to take the 158 males, which is these three sections, 72, 81, and 5. And we have to add the people who said no, which is 81 plus 68, which is this number, 149. Now we counted a group, a cell twice, and that was this 81 people here. If you look, males here include these three, and people who said no include this. So we don't want to double count these 81 people. We want to count them, but we don't want to count them twice. So that's what this represents. The probability of being male is 158 over 336. Probability of saying no is 149 over 336. And the probability of being both together, that double counted category, is 81 over 336. Do the subtraction, you get what you see here. You reduce the fraction and then you convert to a decimal and then a percentage. Okay, so that's how that works. So anytime you have tables, always use the row and column totals. Now I'm gonna apply this because this is pretty much the major concept of the section, is whether events are mutually exclusive or not. Okay, so if I scroll down, now we have dice problems where we do this, but essentially that's the concept that we're looking at. So let me now show you how this works on a problem from the homework. Now here, we're going to, let me screen share here. And let me make this, I've got a lot of things open. Let me, give me a moment, folks. All right, so. Okay. There I am. Now, I'm going to pull this out so I can see it. All right, so here I'm going to use I'm going to use number 6 as an example, because this is hard because you don't have your own chart. You have to make it, all right? So in number 6, it says, in a statistics class, there are 18 juniors and 10 seniors. 6 of the seniors are female and 12 of the juniors are male. If a student is selected at random, find the following probability. Okay. So you have, I would take some notes here, and I'm going to do that here, and then I'm going to put them on the whiteboard. So we have 18 juniors, 10 seniors. 6 of the seniors are female. Okay. And 12 of the juniors are male. If a student is selected at random, find, okay, so we want to know A is the probability of junior or female. B is the probability of senior or female. And C is the probability of junior or senior, okay? So here's what this looks like. Let's put this on the whiteboard now. This is problem 6. So we have, okay, so 6. Here. We have 18 juniors. And we know that 12 of them, 12 are male. And we know that we have 10 seniors and 6 are female. Okay, so how do you break this down? Because we need the chart, right? So what we're going to do, we're going to draw ourselves a chart. I'm going to draw ourselves a box. So I'm going to have a box, and I'm going to have some sections to the box. Something like this. Okay, like that, right? Now, I'm gonna have some rows for this. I have one here. Always remember to leave yourself a row for the totals, row and a column. So I'm gonna have some like that, okay? Now, I have, and it doesn't matter which way you go, but do label. This is going to be male, males, females, and a total. Now we're going to have junior. I'm going to bring this down just a bit. This is junior, seniors, and total. Okay. Now, what we're given here is we have 18 juniors. Okay. So we know that the total, let's go to juniors here. Here's juniors. We go to the total of juniors. We know what the total is of juniors. There's 18. So we're going to put 18 over here. There's 18 junior. There's 10 senior. Okay, there's 10 senior. Like so. Now, 12 of the juniors are male. So 12 of these juniors, 12 of this total 18 are male. Well, if you have 18 and 12 of them are male, then that stands, remember I told you that in this book, gender is binary. So 18 minus 12 is 6. There are 6 female. That's how you get that. 12 plus 6, 18. So when you add, you should get the total, right? Okay, 10 seniors, 6 are female. So of our 10 seniors, 6 are female. We're given 6, so we're going to put 6 here. Okay. Now, of those 10, 6 are female. So here, similarly, we do 10 minus 6, which is 4. Okay. Now, we're going to, we've got our row totals. We need to get our column totals. 12 plus 4, 16. 6 plus 6 is 12. And 18 plus 10 is 28. Now, I want to point out something, that when you do a chart like this, especially if you're having to construct it yourself, the way we just did, okay, you want to check your row totals against your column totals. Here's what I mean by that. 18 plus 10 is 28, okay? So your column total is 28. Your row total, 16 plus 12, should also be 28. It should match the numbers. Sometimes they don't match. If they don't match, you've done something wrong in here and your probabilities are going to be wrong. Okay. So there's my chart. Now let's do our probabilities. Let's go back to the screen here so we can take a look at it. Now, this is problem 6. So it says that we've got my numbers. Okay, so A is a junior or a female. A junior or a female. So here we're going to look at the probability of being a junior or a female, right? Now, remember what I said. If you're not sure, always use the rule that's not mutually exclusive. But we can tell from the chart, obviously, that these are not. These are overlapping categories. Where do they overlap? They overlap here with these 6 people. These are juniors who are also female. So all of our juniors are on the first row, all of our seniors on the second. All of our males are in the first column. All of our females are in the second column, you see. So junior or female. So here we have, this is the probability of being a junior plus the probability of being female minus, we're going to say, this is the probability of being a junior and female, okay? Not or female, okay? This is junior and female. This is my overlap. Remember, the or tells me that I'm adding, but this and is for my overlap. So here, I end up with the probability of junior or female, junior or female equals probability of. Now, here I'm going to say the probability of being a junior. What is it? Well, how many juniors do I have? 18. So this is 18 out of how many? Well, this is out of the whole group. So 18 out of 28. Okay. Now, the probability of being female, what's that? Well, that's 10 out of 28. That's 10 out of the whole group. So here I have plus. Now you could put this all on one line. I'm choosing to do 3 fractions so that I can show you females are, excuse me, not 10. I think I said 10. Females are 12 because we're doing females are 12 right here. These are my females, 12. So now I have 12 and then again 28. Now I subtract the probability of junior and female. Junior and female. So juniors who are female, that's 6. There are 6 juniors that I counted in both categories. So here I'm going to say minus 6 out of 28. So now you could put this all over one denominator, okay? So if we continue that, what we're looking at here, we end up with 18 plus 12, which is 30, which is more than our 28, okay? And that's because we counted these 18, this first row, and we counted these 12. Well, we counted 6 twice. So if I subtract 18 plus 12, that's 30 minus 6 is 24. So this becomes 24 over 28, okay? Let me show you that on the calculator. So here I have 18 plus 12 minus 6, that's 24, over 28. Now remember, we're going to reduce the fraction. So we have 24 over 28. And if you go to math, convert to frac, it will reduce it for you. That's 6 over 7, okay? This is 24 over 28. This is 0.8571, okay? And so that's our first answer for the question. So now, let me go back to this and I'll show you something. This is number 6, and it says a junior or a female. So here, we scroll down. Number 6, 6 over 7. okay, is our first probability, okay, 0.8571. So here, we're going to say that we're going to go and say that this is equal to equal to 24 over 28 and that's equal to 6 over 7, right? Which then reduces to, not reduces, I should say it as a decimal, it's 0.8571, which as a percentage is 85.71%. Okay, that's part A of the question, junior or female. Now, the next part of this question deals with the same table, but it asks us a different question. It asks us for senior or female. Again, I think you can see that we have an overlap. Seniors are this row, 10. Females are this column here. And this time we overlap with this 6 in the middle right here, the seniors who are female. So I'll write this out. This is going to be 6B now. 6B is going to be the probability of seniors or female. Okay. Senior or female. So here we get the probability of being a senior plus the probability of being female minus the probability of overlapping senior and female. Okay, senior and female. So here we get the following. Let's analyze this now. So we have the probability of senior or female equals. Now let's go back to our previous screen. The probability of being a senior, there are 10 of them. 10 over 28. Okay. 10 over 28, the probability of being a senior. Probability of being female is 12. 12 out of 28. So you have this. Probability of being a senior, there are 10. So 10 out of 28. The probability of being female is 12. So this is 12 out of 28. And the probability of being, whoops, 28, the probability of being both a senior and a female is 6. So we have 6 out of 28. So 6 out of 28. And once again, we do some arithmetic. So let me go and put this on the screen. So we have 10 plus 12 minus 6. This is 16. Okay. Now remember, it's out of the total. So 16 out of 28. And if I go math, convert to frac, we get 4 out of 7. Okay. So, and if I want to make this a decimal, I can go here, or I can do 4 divided by 7. I can do 16 divided by 28. It doesn't matter. But if I have the fraction already, I can go math and go convert to decimal here. 0.5714. So this is 16. Put it up. This is going to be 22 minus 6. That's 16. So we have 16 out of 28. This is equal to 16 out of 28. And that's equal to 4 out of 7. So this is 4 out of 7. And here, that is equal to 0. Let me put it down here. This is equal to 0.5714. If I remember correctly, let me check that. So we have right here, this 0.5714, and that's 57.14%. So here we have equals 57.14%. Okay. And then that's our second one. The third one, the third part of this question is the probability of being a junior or a senior. Now, in this case, if you're not sure and you try to use this formula, you'll get this. Probability of being a junior plus the probability of being a senior minus remember, this is overlap. So this is the probability of being both junior and senior. Okay. Well, you can't be a junior and a senior at the same time. So if I tried to do this problem, it would look like this. I would get the probability of being a junior or a senior would be the probability of being a junior, which, if you remember from the previous problem, probability of being a junior is 18 out of 28. Okay, so here we have, this is 18 out of 28. The probability of being a senior, we did up there, that's 10 out of 28. So this one, this is 10 out of 28 minus the probability of being both. Now, I want to point out something. You can't be both, as I said. And that means that because you cannot, that's a 0 probability. This is 0 over 28. Okay. Now, when this intersection here, junior and senior, is 0, this means, and this is the reason why I wanted to write it out once, this means that this, the fact that this overlap right here is 0, means that you have mutually exclusive events. So if it's not immediately obvious, because sometimes it's not as obvious as it is here, this means that you have mutually exclusive events. It's not going to change this answer if you write this in, okay? But if you don't want to write this in, you don't have to. This actually is a version of the mutually exclusive rule. So you could just say this: the probability of being a junior or a senior is equal to the probability of being a junior plus the probability of being a senior. Okay. Because they're mutually exclusive events. Now, in that case, obviously, in this particular scenario, you have to be in either group. So in this case, that's equal to, if you look up top, 18 plus 10 is 28. So you'd have 28 over 28, and that would equal 1. So this equals 1, which equals 100%. Now, that, if you remember, is an absolutely certain event. So this means that this is absolute certainty, which doesn't usually happen, but it does here. Because you've included the whole sample space. Now, these are just a couple of extra notes for you with that particular one, but I hope that answers this question, and I'll see you in my next video. Thank you very much.